Hey everyone, I'm Josh. I'm a first-year computer science student who loves web development, and today we're going to be talking about the cause of errors, a deep dive into cross-origin resource sharing. So, you wake up one day and you say to yourself, I have this amazing idea for a website. You've got a nice name for the site, your divs are centered, and everything is going to plan. Then this happens. So many errors, cause errors. And you're probably thinking to yourself right now, that's it. I've had enough of JavaScript. Can I go back to Python now, please? And that awesome site never gets created. So what exactly is CORS, and why is this error happening in the first place? If we look at the error message, we see some really weird terminology, like origin, CORS policy, access control, allow origin, and the cherry on top is opaque response. So, to first understand CORS, we need to go back in time to understand something else. Now, the year is 1995, probably, and the web is gaining popularity. Thousands of new sites are being added each day, but there's a problem: security. And we're going to consider security from a worst-case scenario. Not that one. Online banking. So, there's this bank that we use called securebank.com. And it works on two assumptions. Cookies are sent on every request, and the bank has no two-factor authentication. That just makes things simple for us. And you're a happy customer. You have a nice bank balance. Everything is fine. Then this happens. All your money is gone. This is fine. So what happened? Well, earlier that day, you remember you visited a site called cssisamazing.com. And you clicked on it because you know that's not true. Then shortly after, all your money was gone. Was it the CSS? And it's simple. When you clicked on that site, it sent a request in the background to securebank.com saying to send all your money to Mallory without you knowing a thing. And remember, cookies are attached on any request. They act as a credential, a key to your safe, and anyone who has this key can open the safe, take it out, put something in. And what just happened is called a CSRF attack, cross-site request forgery. And the general idea is a request that only you should be able to make is made without you knowing. Think posting something to social media, deleting a file, or even transferring money in this case. Okay, this needed to be fixed fast. Introducing, yes, you guessed it, no you didn't, the same origin policy. Now, hold up. This is a talk about CORS. Now you're introducing another weird acronym. I want to know how to solve my CORS errors. Now, please. It will all make sense soon. But first, what's an origin? Cross-origin, same origin, what do they actually mean? Well, take any URL. Here we have something from the React documentation. And you're going to remove the path. Think of the path as anything that comes after the .com, or .NET, for example, the part highlighted in blue. And that leaves us with this, the origin. Simple, right? Well, every origin has three parts: a scheme, a host, and a port. Now, the port is, the scheme is the protocol used for transmission. The host is the name of the site, and the port is the service to be accessed. So, the scheme is the first part of the URL. Here we have HTTPS. You can think of HTTP or FTP, really any scheme you can think of. You also have the host. That's the name of the site. That's, securebank.com, csstricks.net. And the port, just a number. It's always there, but it's usually hidden. And if any one of these parts changes, we have a different origin. So, we have three URLs here, and they all represent the same origin. Why? Well, they have the same scheme, HTTPS, the same host, tailwindcss.com, and implicitly, they will all have the same port number, usually 443. So, logically, they all represent the same origin. Now, what would different origins look like? Well, they have the same scheme, HTTPS, but clearly, the host is different. Secure Bank compared to LinkedIn.com. So we have a different origin, or cross-origin. So, cross-origin, same origin, makes more sense now, right? Back to the same origin policy. So, what is it? It's a browser-enforced policy. And simply put, it means no cross-origin requests from scripts are allowed. Only same origin requests, hence the name same origin policy. Now, this doesn't apply to images or fonts or even CSS files. That's all fine. And any attempt to make a cross-origin request would be blocked by the browser and it wouldn't be sent. This is awesome, right? Mission success. The web is more secure. Cross-site request forgery attacks have one less attack vector they could exploit. The day is saved. Well, technically, yes and no. Cross-site request forgery attacks can still happen, but that's a talk for another time. So, it's save the day, sort of. The web continued to grow. There was all these data, all these APIs that we cannot access. It limited developer creativity. It was too restrictive. But there's always a way. Developers came up with clever ways to overcome the restrictions of the same origin policy. Think browser extensions, JSONP, which stands for JSON with padding, or make requests in a different language. This is the way. Well, not really. They were hacky and required a lot of messy code to work, so they were never really adopted. Developers like things that are simple, and that's why. So, developers want to use all this data, but there's no official and secure way to do it. Browser developers realized this, and the same origin policy was relaxed a bit. So they implemented a way to relax the same origin policy. Introducing, yes, for real this time, cross-origin resource sharing. Okay, now the idea is simple. Allow one site to make a request to another origin, and not get a bajillion errors while doing so. And the name makes sense. Cross-origin allow a request from one origin to a different origin, and resource sharing allow one site to share their resources, API endpoints, with another site. Now, the basics. Rather than making the browser block a cross-origin request immediately, how about we let it be sent and only pass the response data back to the client if the server explicitly allows it. Cookies are also not included by default here. So, how it works. The client initiates the cross-origin request as normal, and the browser intercepts it before it's sent and sees its cross-origin. The browser adds a HTTP header called origin to the request, and the browser sends the request to the server. This is what it would look like logically. So you have the origin, and let's say we're on securebank.com, it would be securebank.com. So the server then receives the request and does one of two things. The server knows nothing about CORS and was built on the assumption that it could only receive same origin requests. Or the server is aware of CORS and responds accordingly. So in the first case, the CORS is not aware. The server is not aware of CORS. And since the server was built on the assumption that it could only receive same origin requests, it assumes it's a request that it must have made to itself. So the request gets executed, and it's sent back to the browser. The browser receives the response, but it's not happy. These are errors. So why CORS errors happen? Well, when sending a cross-origin request, the browser expects the response from the server to include a specific header called the access control allow origin header. The name makes sense. And the value of this header is, of course, an origin. And the browser checks if the value of this header that it received from the response from the server matches the origin of the client. And if they match, perfect. Everything is fine. If they don't, an error happens. Now, what would a failed request look like? So, we're on securebank.com. And we're sending a request to CSS is amazing, let's say. So the browser is going to add the origin header, http securebank.com, but then the server is going to receive this response, but it doesn't know anything about CORS. It just does the request and sends it back. So there is no access control allow origin header in the response. So it's just blank. And that's why the error happens, because the browser isn't seeing the same origin on the client as it is in the header. Now, case 2, the server is aware of CORS. The server checks for the origin header, and it tests the value of this header against a whitelist of allowed origins. Think an array, for example, of origins that a server will allow cross-origin requests. And if the origin that made the request is contained in the list, the access control allow origins header is set to this origin, otherwise it's left out or a random value. So, the browser receives the response from the server, checks for the access control allow origin header, sees that it has the same value as the client's origin, everyone is happy, the data is passed back to the client, no errors. And this is what a successful request would look like. So again, we're on securebank.com, we send the request, the browser adds the origin header, and then the server receives the request, okay, I am allowed to make I am allowing securebank.com to make a request to me. So then it sets the access control allow origin header to the client's origin, sends it back, and the browser sees this, they match, perfect. So, we're done, right? Not quite. So, there's a minor problem. Even if a CORS request is rejected, the server will still execute the request. So, could I just send a delete request and cause a ton of damage? Introducing the pre-flight. So, the idea is simple. It protects the server from executing potentially dangerous requests, achieved by making the browser ask for permission first before sending the actual request. And this is usually achieved by sending what we call an options request, or to make it more simple, a metadata request. And this pre-flight request just tells the server what the actual request will look like, what method it's using, what headers it's going to send, what the actual payload will look like. So it puts the server in charge of what requests it accepts. And the general overview is the client initiates a cross-origin delete request. The browser sees this as a potentially dangerous request, and the browser sends the pre-flight request to ask for permission before sending the actual request. The server checks if delete requests are allowed. Am I allowing this sort of request? Yeah. And if it does allow these requests, it sends a response back to the browser saying, yes, I do allow this type of request. You can send it now. So then if the request is sent, otherwise you get an error. So when is the pre-flight sent? Well, the rules are a bit confusing, but there is a reason. So it will be sent on any other methods other than get, post, or head. So think put and delete, for example. Content types other than text, plain, multi-part form data. Think, videos or MP4 file formats. Or if the client sets any custom request headers, it will also trigger the pre-flight request. And lastly, the client wants to send cookies cross origin, so by default, it will require a pre-flight request. So, to summarize, CORS is actually there to help you, not to restrict you. CORS allows developers to create content-rich applications, and don't dislike CORS, dislike the same origin policy. Status 200, CORS is awesome. Thank you very much.